Hello, everyone, and welcome to Hoot 71, how to set up multi-cluster Istio on AWS EKS. So I'm joined by Sanjeev today. Sanjeev is a senior specialist solution architect for containers at AWS. Sanjeev specializes in service mesh and platform engineering, generative AI, prompt engineering, GitOps, AIC, auto-scaling, cost optimization, and observability. How are you doing, Sanjeev?
I'm doing great. Thank you very much, Peter, for inviting me to the show. I'm very excited and looking forward to talking about multi-cluster Istio today.
Awesome. Well, thanks for coming. So, I think a couple of weeks back is when I did the multi-cluster episode, and then Sanjeev reached out and he's like, "Oh, by the way, I've done like these at AWS. We've done these Terraform scripts, and we have some scripts and setups and things that people could use to actually set up Istio multi-cluster on AWS." And I was like, well, let's come on the show. Why not? So it's always great to hear from people who are doing this with the customers as well.
Absolutely.
Yeah. So just a call for anyone who's watching. If you have any, if you're doing any Istio related work, anything that you think would benefit others who are watching this every couple of weeks, don't hesitate to reach out, and we'll get you on the show. We'll talk about it, and we'll get your message out, I guess. Um, all right. So I hope I introduced you well. Let me know if I missed anything, or if you want to add something else to it.
No, I think yeah, you introduced me great, and by the way, again, I'm Sanjeev Ganjihal. I've been with AWS a little over 3 years, and I am currently supporting financial services industry within AWS and supporting a large customers in the FSI space, whether it is banking, capital markets, insurance, fintech. So I'm supporting plethora of customers there, and I majorly focus on ECS, EKS, and all cloud native technologies. So helping customers accelerate their app modernization journey on AWS.
Awesome. Well, that's great. If you're here, if you're working with Istio, say hi in the comments. And I also typed in earlier, if you have any questions, feel free to ask at any time. Well, I'll hand it off to you now, Sanjeev, and let's get started.
Absolutely. Again, the major focus today is going to be Istio multi-cluster. There's so many patterns or deployment topologies I should call out. Basically, when customers look at a service mesh, the thing that comes to mind is how do we solve application networking challenges, right? So we're dealing with a lot of microservices. We have polyglot frameworks today. We use different programming languages. Apps are written in different programming languages. How can we implement application networking capabilities using a service mesh? And everyone today knows Istio is a popular service mesh, which is widely adopted by a lot of organizations today. And they're running service mesh at scale, but typically a lot of customers run service mesh on a single cluster. This is good for what do I call load environments, or even to some extent in production. But there are a lot of use cases where we have seen there is huge focus on isolation, fault tolerance, availability, and regulatory requirements, compliance, and they want that separation of concerns, right? So they want to have multi-region is another use case where we're seeing customers wanting to implement a service mesh across multiple clusters, across multiple regions. And again, spanning a single flat network is again a challenge because you want to have separated network as well, so that you can run one cluster, one Kubernetes cluster in a different VPC, another Kubernetes cluster in a different VPC. So multiple networks is another key aspect that most of the customers are exploring today, because you also want the network isolation, and how a service mesh will help those customers addressing these use cases, right? So today we'll be diving deep into this aspect, where we'll be majorly focusing on Amazon EKS. A lot of customers are using Amazon EKS today to run their container workloads at scale. And for their application networking capabilities, whether it is traffic management or observability, security, resiliency, they're looking at Istio to address those use cases. And again, MTLS is another popular use case for customers as well. And Service Mesh is basically solving those capabilities. So to start with, right? So I've been working with a lot of customers. They have the standard topology, which is shared control plane, right? Or I would say single control plane. What that means is if I'm running a multi-cluster setup, I have a service mesh, which is basically running on the control plane is basically running on a single cluster, while the other cluster does not run any control plane. They basically have everything is basically handled by the control plane running in your primary cluster. The challenges we have seen with that setup is basically if your Istio dies in your cluster one, your basically service mesh capabilities are completely gone, right? So you don't have the ability to even leverage any Istio constructs. So Istio D, the core component of the control plane, if it goes down in your cluster, you do not have the abilities to explore the traffic capabilities or observability. So that's a challenge that we have seen with a lot of our customers, and they've been talking to us and telling how can we look at the multi-cluster pattern where we have two different networks. We want to have high availability resiliency, even with the control planes. There's definitely a few aspects to keep in mind with this, because single control plane, you have fewer number of resources, right? So whatever is your resources that get deployed, now you're basically focusing on two different clusters. So there's increase in the number of resources that will be running on your clusters, but look at the benefits of it, right? So you're basically getting high availability, fault tolerance, resiliency, and then two different control planes. One control plane dies, you still have the other control plane, which is basically taking care of pushing all your Istio specific configurations to other clusters. So in today's session, we'll be diving into this aspect where we'll talk about multi-primary control plane and multi-network on Amazon EKS.
Yeah, I didn't know if you wanted to share the screen yet or not, because nothing. Uh,
Yeah, absolutely. Let me go
I'll
ahead
share
and
some. Yeah, yeah, but the idea is like single cluster, single control plane. It works. However, you don't get the high availability, you don't get the resiliency, right? And if that goes down, it goes down. There's nothing else to back it up in that, and it's in that sense. So the idea is, let's set up multiple clusters with primary clusters. Primary basically means it does have a control plane running into it in it, right? So if one goes down, you still have the second one that can take care of the configuration there. All right, so I've shared your screen as well. Also, this is the repo. Well, I'll let you
yeah.
let you talk about it. Yeah, you probably know more about it than me.
Yeah, there's been a lot of demand from customers like, hey, Istio is an open source project, but how can we run things related to Istio? How can we learn more about Istio, and how can we explore different patterns specific to Amazon EKS, right? So what me and other specialists within the organization are working on is building patterns and blueprints for customers so that they can go and run these patterns and deploy Istio on their Amazon EKS clusters. So this is an open source repository. It's under AWS samples. It's called Istio on EKS. And we do have a lot of modules where we're covering how do you get started with Istio, and how do you handle traffic management? How do you handle resiliency? How do you handle security? So we are building different modules. Again, these are going to be catered towards AWS because customers want deploying their container workloads on Amazon EKS would love to hear or know how things work in the world of AWS. It's not more open source Kubernetes, but it's going to be majorly Amazon EKS. And in today's session, we'll basically be looking at the multi-cluster, multi-network, multi-primary pattern. Again, we quickly talked about the use cases: fault tolerance, high availability, multi-tenancy isolation, compliance. Again, deployments as what canary deployment. Some customers have asked for A/B testing, canary deployments, and having a multi-cluster where you can route traffic in two different regions is a big win for customers as well. And again, if you're modernizing, if you're doing like a strangler-fic pattern or any modernization where you want to move your monoliths to microservices, multi-cluster might be beneficial, because you can run your monoliths in one cluster, slowly start migrating and make it part of a service mesh, right? So migration and modernization is another aspect where customers are looking to explore this particular pattern. And to talk about the architecture, right? The architecture is pretty straightforward. So you have a AWS account that you deploy your EKS clusters. So we basically look at two different networks here, because we're talking about multi-network. So we have two different VPCs, 10.1 and 10.2. Again, this is just for an example purpose, but typically customers would have their own networking CIDRs that they'll be using in their production deployments. But just for reference purposes, we have just used 10.1 and 10.2 for demonstration. And if you look at the architecture, we have two EKS clusters running out there. And each cluster has Istio control plane running, because if you look at the diagram, there is Istio D running on both the clusters. Istio D is the control plane, core component of the control plane, responsible in injecting all the service proxy configurations to the data plane, right? So the data plane is basically, you have your services running, and an Envoy proxy is injected to each service, right? So it runs as a sidecar where it receives the proxy configuration from the control plane. So you have both the Istio control plane running out there. And then we have Kubernetes API servers. Again, these are managed by AWS. As EKS is a managed Kubernetes offering, we take care of the control plane, which is API server, scheduler, controller manager, cloud controller manager. All these components are managed by AWS. The goal of this implementation is basically you run different services or microservices on two different clusters. How can we achieve cross-cluster communication? So what are the aspects that are involved today if we have to achieve cross-cluster communication?
So in this diagram, we have like a single AWS account, right? And within that account, two VPCs, right? Two clusters and two different VPCs.
Correct.
Is there any difference if there's multiple AWS accounts? Is that like a practice that some people do, where they would have like different accounts for like prod or dev or staging or something like that, or maybe per region even?
Yeah, there is definitely the AWS well-architected framework recommends you separate your environments per AWS account, right? Again, from a billing perspective, from cost perspective, if you want to tie them back to your business units, you pretty much would recommend taking a separate AWS account approach. The pattern would vary a little. Again, we are working on an advanced pattern where we'll be showcasing two different AWS accounts, EKS clusters running in two different AWS accounts, and how can we achieve multi-cluster, multi-network, and multi-account solution, right? So this solution today is scoped to a single account, but you can think of two EKS clusters running in two different VPCs, and you can think of staging in a production cluster running in a single account. So this pattern is basically addressing that. In the near future, we'll be building another one where you'll see two different AWS accounts, and we use the concept of RAM, Resource Access Manager, with an EKS, with an AWS. So what we'll do is we'll basically share whatever Istio constructs from one account to another account using Resource Access Manager.
But theoretically, or well, let's say theoretically, if I had two separate accounts, would there be anything different that I would have to do to connect the clusters, or are the steps are pretty much the same, right? It's like it's still two different networks, right? But this time they're also in two different accounts, right?
Correct. There's going to be the isolation boundary where the service accounts that we use for API servers to communicate, right? So I'll be talking about that. So how do we share those resources to another AWS account, right? So that's the complexity where we'll have to bring in a solution like Resource Access Manager, because these constructs running in one AWS account cannot be accessible in another AWS account. And there needs to be a mechanism where we can share these resources. That way, the discovery piece is solved using Resource Access Manager.
Okay.
And we can also explore another solution, which is Cloud Map. Again, think of it as a service registry, right? So you can have two different AWS accounts. You have your EKS clusters running in two different AWS accounts. And then you can have a Cloud Map, which basically has all your resource entries, right? So whatever services you're running, the IP addresses or the custom names. So that's another implementation pattern that we're kind of looking at. Pretty soon we'll be focusing on developing those and sharing with our customers as well. So in this, the major goal is, right, so we're running two different networks, two different EKS clusters. The challenge is how can these resources, how can the control plane, the Istio discover the endpoints running in another EKS clusters, right? So in Kubernetes, everyone knows API server is the heart of Kubernetes, right? The entry point into your Kubernetes cluster. So the API server is the only component that you deal with, whether you're using kubectl or you're dealing with APIs, you pretty much talk to the API server. So Istio also leverages the same mechanism, relies on API server to basically discover endpoints running in the other clusters. So basically two API servers have to be discoverable, and we'll talk about how that works. So we'll be basically focusing on creating some remote secrets so that the control plane in cluster A knows how to communicate with the API server in cluster B. So we'll be basically leveraging the mechanism of remote secrets, usage of service accounts, because again, they are responsible in basically allowing these API servers to discover each other. And there's another aspect, which is, again, not depicted here because it will be too detailed architecture. It's also important you establish trust between these clusters, right? So how does that trust work today? So you have the option of leveraging certificates, right? So you can either bring in plugin certificates, focus on a root certificate and have intermediate certificates running on both the clusters. And then there is a common root certificate authority, which will basically handle certificate management for your workloads. So the trust is basically established using certificates. And in this pattern, what we have done is we have used Terraform to create that root CA and intermediate CAs, and I'll be walking how that works. But just from a understanding perspective, we have not used any external solutions like Cert Manager. That's an improvisation that we're going to make to this pattern, where we'll incorporate Cert Manager so we don't have to deal with creating any certificates, right? So again, some organizations may feel, hey, what if intermediate certificate is compromised, right? So we don't want that hassle. So in that case, we'll rely on Cert Manager, wherein you'll just create certificate signing requests, and Cert Manager will basically be responsible in creating certificates for, again, maybe talking to Let's Encrypt or maybe talking to some other entity which is providing certificates. But the goal is to replace plugin certificates with Certificate Manager. So we talked about the workload discovery piece using API server, the control plane, and then there is trust. And the third piece is how do we communicate across these clusters, right? So there's something called east-west gateways, which you see in the architecture. So these are cross-cluster connectivity piece that we are addressing. Typically, what Istio offers is ingress gateways and egress gateways, right? Ingress gateways are entry point into your mesh, and if your traffic has to go out, you pretty much leverage an egress gateway. Those are solving your north-south aspects of it. But how do we address east-west, right? So when I say east-west, there are two clusters. You have services running across both the clusters. And how can I make sure I have the traffic without going out of the cluster? How can I just make sure I just use a separate construct for east-west communication? So Istio has introduced a construct called east-west gateways. again, from a cloud provider implementation, these are going to be load balancers. And the networking aspects, again, if a flat network, there's plethora of use cases that you can look at. You can either peer those VPCs and make a single flat network. That's one option to look at. The second option, what we did is basically you have these load balancers. You expose these east-west gateways in the form of load balancers, and then you use those load balancers as a mechanism to communicate, have the service-to-service communication. So we'll be talking about how that works in the back end. Will show how that thing works. But at a high level, do understand it's basically focusing on leveraging east-west gateways. So the three aspects are workload discovery, workload connectivity, and the common trust. These are the key aspects to keep in mind when you focus on multi-cluster, multi-primary, and multi-network implementation.
And I just one thing to add, like I know when I started learning about Istio and all these gateways and everything, one thing that was like I always taught when I started was, oh, you have ingress gateway, okay, that's one thing. You have egress gateway, that's the second thing, and then you have this east-west gateway. So you have three different things, right? Technically it's the same thing, it's just configured differently,
Yeah.
right? That's what it is. It's still an instance of the Envoy proxy. Envoy proxy is what drives the Istio mesh, right? It's just configured differently. That's what it is, right?
Yeah, you're absolutely right. The ingress gateways, the egress gateways, the east-west gateways, they're all Envoy proxies, and we're just the implementation aspects are kind of varying because we use a ingress gateway for the entry into the mesh,
Yeah.
egress for exit, and east-west is basically the constructs to use layer for the service-to-service communication between two different clusters. So. And another key point that I'll be specifying in this particular pattern is it's the two clusters can be single region, because again, in Amazon, in AWS, you can have resiliency fault tolerance because your workloads can be spread across multiple availability zones. So there is no necessity for you to basically look at multi-region. You can still be in a single region and have these two clusters running and have different AZs, right? So each cluster can span three different availability zones, and then you can have workloads running. So you can either do multi-region, or you can still stick to a single region and two clusters across the same region. I just want to call that out. This pattern would work for both the scenarios. And quickly, what I wanted to show is we basically have automated everything end to end. So we have these Terraform configurations where if you look at the repo here, we have EKS 1.tf, EKS 2.tf. The main goal of this particular modularized Terraform code is provisioning a specific VPC for that EKS cluster. The main building block is having a VPC. So the first piece basically addresses the VPC. The second one, the module that we are referring to again, is a Terraform standard module for EKS. And we are building an EKS managed node group, implementing some security groups, creating namespaces for Istio, and creating the secret, right? So we talked about how do we implement secrets, establish the trust with between two EKS clusters. So we'll be creating a root certificate, and we talked about using plugin CA certificates. So we basically rely on Terraform here instead of using other mechanisms. We baked everything into this. Again, I want to call out another specialist who worked with me on this, Vijay Chintalapati, who has contributed with writing this code with me. So we've basically automated the certificate management process. And we're also deploying some add-ons here because Istio needs to be installed, right? So there is we've used Helm charts. Again, you can pretty much use traditional YAMLs. Operator again is going away, so the recommended approach is only going to be Helm chart. So we have different releases. So we have a base, we have Istio D, and there's different components that are coming with it, right? So the Istio Ingress, and we are talking about the East-West gateway. The Ingress gateway is majorly responsible for the entry into the mesh, and we are also implementing the East-West gateway for the service-to-service communication across clusters.
So in this scenario, we're just using Terraform is using the Helm charts to install Istio. I also want to call out that at Solo is an AWS partner, right? And we do have
Marketplace.
marketplace entries. We have Solo's Istio distribution, where you can just go click on it. Basically, it's a one click, and you can get Istio installed that way as well. So it's on Bitly Solo AWS if anyone wants to
Absolutely.
check it out.
Yeah, and thanks for calling that out as well. So some customers who do not want to go through the open source complexity, Solo is doing a great job there. The marketplace add-on is helping a lot of customers because it's just a one-click solution wherein they get a fully blown Istio in their EKS clusters, and pretty much leveraging native Istio constructs after that, which is virtual services, gateways, destination rooms. So it's basically just reducing the operational aspects of managing an entire service mesh, right? So that's a good thing. Customers have the ability to go to marketplace add-ons and explore distributions from Solo. If you see these east-west gateways, we have made sure they're, again, we kept it internet facing. Again, from a private network, as I mentioned, you can either peer these VPCs and you can basically have a complete private network as well. It's a little complex to demonstrate that end to end. So from a overall prototyping perspective, we kept it a public facing so that it's easy for customers to grasp the concepts and later fine tune to their requirements, right? So if they want to be fully private, they'll be exploring other alternatives and other constructs within AWS. And we have exposed some ports, standard ports, and we've also talked about the Kubernetes service accounts, right? So we are creating Kubernetes secrets because these API servers have to basically discover themselves, and so that the control plane can discover the endpoints and push configuration through the API servers, right? So we're creating these resources in the Terraform. So it's pretty straightforward. Everything is automated today. Customers don't have to go through the hassle of implementing these on their own, like just install EKS separately, Istio separately, and then these resources separately, right? So everything is kind of automated in this Terraform. And it's pretty straightforward. We've created a simple locals TF where you just pass in what your VPC siders are going to be, what region you're going to use. If you're looking at multiple regions, there's little change that we make in the region variable. You can do region 1, region 2, and specify 2 different regions, and it still works. And you basically specify some EKS settings and then Istio specific settings, right? So the 2 EKS clusters are just part of a single mesh. It's like a big mesh within which you have, again, think of it just as a logical boundary, right? So you have this bigger logical boundary wherein your 2 EKS clusters are part of that mesh. So the mesh idea is going to be pretty standard when you focus on getting the multi-cluster implementation. The network names and the cluster names are critical because here you'll be focusing on 2 different networks, so the namings are going to be different for your network on cluster 1, network on cluster 2. And we do have, again, if you don't want to run Terraform apply, Terraform plan, all that stuff, we have some shell scripts as well for customers. They can just go, they can run the deploy.sh, which will basically create an end-to-end implementation deploying EKS cluster 1 VPCs and 2 VPCs, 2 EKS clusters, and all Istio-specific constructs, right? So within a single click, you basically get the entire setup ready. So I've already built the cluster just so that it takes 20 minutes for me to build everything. So just in the interest of time, I have already created two EKS clusters. And the destroy shell is basically, if you want to clean up after testing this, you pretty much run the destroy. And then we also have some scripts which we'll use in the demo to validate how the cross cluster sync works and how do we make sure the load balancers are ready or not. So we'll just evaluate those pieces. And then from a application perspective, right, we're just talking about implementing EKS, Istio across clusters, but we do need apps that are running on the clusters, right? So I'll just quickly cover. So we used Helm chart again there. So we have a gateway YAML. Again, this is going to be a cross-network gateway that we'll be leveraging. And if you look at it, in Kubernetes, everything is based on labels and selectors, right? So we'll basically be using this label, which is East-West Gateway. And I also want to talk about SNI aspects here, right? So there's auto pass-through, and then there is SNI standard mode. So the auto pass-through mode is why we're using this is basically you want to expose your services running on cluster. So anything app.svc.cluster.local, right? So anything .local, you don't have to basically go through the ingress gateway and pass an SNI header. Again, SNI is a server name indication. So if you don't want to go through that hassle, you can just set auto pass through so that the discovery is basically the services is discovered through local. Any service that has .local, the network, the East-West Gateway can basically discover them. So
Yeah. And there's also like there's pass through mode, but that one does require you to basically create a virtual service
correct,
and then specify the destination or do the matching on the SNI to
correct,
point it. With auto pass through, you don't have to do that, right? It's going to be well, you don't need a virtual service. That's what
correct.
you basically get. Yeah.
Absolutely, yeah, you're right. So we don't need a virtual service here. We just use the auto pass through option here. So in this example, we're just going to be using that, and we have a simple application. Again, it's a Hello World deployment. We are running two different versions, V1 and V2. We'll talk about V1 running in EKS cluster 1, V2 running in EKS cluster 2, and we'll showcase how the cross-cluster communication and cross-cluster connectivity works in today's demo. And we have a service again which is needed. We want to expose our application. It's just going to be a simple cluster, not a load balancer. It's just a cluster IP exposed on port 5000. And then we also have another application which is a sleep. We'll talk about the remote secret aspect. This is again, we talked about using the secrets. Again, if customers use Istio Kutl today, there is a create remote secret command that they can use. But for this implementation, they don't have to worry because we've automated this end to end. So through Terraform and Helm charts. So this is again creating that remote secret and passing in the cluster name here because we need cluster 1, cluster 2, the cluster 1 secrets to be shared in cluster 2, cluster 2 secrets to be shared in cluster 1. So that is how the workload discovery kind of works. So we've automated that as well as part of the Helm chart. And you can pretty much go to the patterns folder in this repo and you should see this pattern. And going back to the demonstration, as I mentioned, I have two different clusters running. So I have EKS 1A and EKS 2A, both running in US West 2 right now. And they're running Kubernetes 128. And if you go look at the EKS cluster, so if I look at my resources, I have few deployments running. So there is an East-West gateway. There's also an ingress gateway running, but we'll majorly be relying on East-West gateway for our cross-cluster communication. So on the cluster 1, we have Hello World V1, and we also have the sleep application running here. And from a compute perspective, I'm just using a single managed node group. I'm running a T3 medium, 2 instances, T3 medium instances. Again, this is more than enough for this pattern to work. But again, if you have more workloads, again, you're going to be focusing on building or using different instance types for your use cases. In the same pattern, we have EKS 2A. Again, that's the second cluster. And I do have my Hello World V2 running there. And I have the East-West gateway running. And I also have my core components, which is Istio D and Sleep application running there.
So it's basically two clusters set up more or less in the same way. The only different, both have Istio installed. One has V1 Hello World, the other one has
Yeah,
V2 Hello World, and the other difference is the when the Istio was installed with the Terraform, it was tagged with a different cluster name, and it was tagged with the different network name.
correct.
There's a question that came in. I'm going to read it. So, could you share your thoughts around two accounts connected through a hub account that has a management cluster where the Istio control plane lies? What are some pros and cons around this approach?
Yeah, good question. So if you look at this, it's the model that we are referring to is the external control plane model. Think of it like a hub and spoke, right? So this is your AWS account where I'm just hovering my mouse. The Istio control plane is completely external, right? So in this scenario, your hub account, you'll be deploying your Istio control plane, and these two remote clusters would be running in two different networks again, two different clusters where you will just be running your services, and the control plane will be completely separated. Like you can run them in the hub network, and you can basically use the same constructs, again, workload discovery, workload connectivity, and establishing the trust, right? So it's just that the control plane aspects are not running on either of clusters. You're just thinking them of two different remote clusters, but the goal is hub and spoke model here. So you're basically relying on a control plane which is running somewhere else in a different account, and there's little complexity here in this model, especially on AWS, because the way the VPCs are regional, right? So basically, look at remote cluster 1 running in a VPC 1, remote cluster 2, VPC 2, and your external control plane may be running in VPC 3. So in this, the complexity which I talked before is going to be how do I solve sharing resources, right? So again, that complexity will come back in this scenario, and we'll have to rely on solutions like Resource Access Manager. This, what are the pros and cons? Again, not a lot of customers are looking at external control plane, right? So unless the main use case for external control plane is I don't want any Istio to interrupt my workloads. I'm running independent clusters where I don't want to have any operational burden of running Istio. I just want to run it separately somewhere else. Or maybe this is culture within the organization where there's a separate team that is managing Istio for you, right? So all developers care is, can I have access to my EKS clusters? Can I go deploy my workloads there? Can I use virtual constructs like virtual services, destination rules, gateway? Can I manage things on my own? In those scenarios, this model is more applicable because in this model, what we talked today is this model, the second one, where we have a primary cluster, cluster 1, cluster 2. We have control planes running in both the clusters, right? So this is a model very popular and majorly used because there's a platform team which is responsible in building everything, and developers majorly focus on deploying their workloads and running some, giving them self-service abilities to create virtual services destination rules, but not do nothing with gateways or egress gateways, east-west gateways. So that control basically lies with the platform team. So that's what we're seeing a lot these days, because centralized teams, platform teams, or you can call CCOE, Cloud Center of Excellence, they basically have the control aspects. The cons of this model, as I mentioned, is again, complexity in setting up. That's a major aspect that I would look at if you want to separate or use kind of a hub spoke model. This model is pretty easy, and this is the easiest model where you just have a control plane running in a single cluster, and you just use the remote secret to basically communicate with the remote cluster, with the API server and the remote cluster.
Couple of more questions. Ken LinkedIn is asking, T-class instances are subject to throttling for both CPU and network bandwidth. Is there anything I should do around monitoring the effect of this inside either EKS or other options?
Yeah, again, the reason why I use T3 medium is from a cost optimization perspective. When we run these workshops with other customers, when we demonstrate, we make sure we have cost in mind, and that is one of the driving factors. You see T3 medium, but again, a lot of customers either go with compute intensive, whether they use C5, C4s, or if they want to be majorly memory focused, they basically use R instances or M instances. So it totally depends on what your requirements are. And again, these instances are not standard. You can go modify these instance types if you want to leverage these patterns. To answer your question, it's just the cost optimization aspects why we used T3 medium here. And there's no hard and fast rule to just stick to that.
Yeah. So mostly for the demo in this case for now.
Correct.
Right?
Yeah, just for the demo purposes. And you can run them on any instance as long as you're not suffocating the Istio control plane, not giving enough resources for the control plane to function. Again, these are going to be smaller T3 and T2 micro. Those instances have very less compute in terms of CPU, memory, network bandwidth. So typically, it's recommended to use bigger instances than the T family.
And then another one from Jeremiah. He's asking, is there a way to limit which services in a cluster are exposed across the mesh to the other cluster?
Yeah, that's a good question. Again, you can basically leverage Istio policies, and you can basically limit what services can talk to another service across a cluster. So you can use native Istio policies, or you can also use Kubernetes network policies. Again, there needs to be an enforcer running on your cluster. We also launched VPC CNI network policy implementation recently. So there's a controller that runs within your EKS cluster, which will handle the network policy enforcement. So earlier we did not have that. Customers had to rely on Calico or Cilium for the network policy enforcement. But today we do have that implementation, which customers can use.
Yeah. So in short, like the way that I think about this is even if you're on a single cluster, and if you think about namespaces, right, and having workloads in different namespaces, those are all exposed by default. So what you would do is you would do authorization policies or something like that. And then similar thing, if you zoom out a little bit, multi clusters, right? By default, everyone can reach everything, right? But then you would use the authorization policies.
Absolutely.
To limit.
Correct. Yeah. That or natively network policies.
Yes.
Choices for customers. Again, if they want to be more Istio native, use authorization policies and kind of rest.
Yeah.
I know we have a few minutes. I know we just talked about it. I quickly want to run through
demo. Yeah. Well, let's see that it actually works. We talked about it for so long, right?
Yeah. For that, what I have to do is I think I have to pause sharing my screen and
and I'll as soon as you reshare, I'll click again. And everyone who's watching, feel free to like post your questions, your comments. Even if we don't, like, even if you have questions later on, if you post on, I think you can still post on LinkedIn. You can definitely post on YouTube, post on Twitter or X, I guess, and we'll get to you after the stream as well, and we'll answer these.
I think everyone can see my screen, right?
Yes. Yeah.
So I do have, I pulled down that repo, and basically we did look at the patterns, right? So I'm just going to get into the patterns, and here we have the multi-cluster, multi-network primary. So I'm just going to So here I have some scripts like I talked about. So we do have all the Terraform configuration and also the scripts. So what I did is I already, if you look at the GitHub repo, it has under the deploy section, if you just go to scripts, there is basically deploy.sh and then there is destroy.sh. That deploy.sh basically created all the resources for me, and we've already looked into the EKS console to validate every resources available out there. So I'm not going to run that command. All I'm going to do right now is I'm going to basically go back one level, and I'm going to run my cluster context. Again, this is very important. We need to basically make sure we are using the right cluster context, because I've seen, again, I've been with Kubernetes for more than 8 years now, and I've seen contexts. If you're not setting them properly, you may be running things on a different cluster. So it's important you have the right cluster context. And even if you're doing any kubectl operations, make sure you're not running them on the wrong cluster and causing problems. Right? So it's important we set them up. And the next step that I want to do is, now that we have all the east-west gateways, Istio constructs, everything running, we basically have to check whether the load balancer is ready or not, right? So we expose them as load balancers, the east-west gateways as load balancers, and we have to make sure they're ready to serve the traffic, right? So the load balancer basically relies on target groups, and the target groups have instances as their backends, right? So we need to validate if the load balancer is ready or not. So I have another script which will basically validate the load balancers are ready or not. So basically what it will do is it will look at your cluster context, and it is running some readiness checks for your EKS cluster 1, and it's coming back and telling us that, hey, both the east-west gateways, one for EKS 1A and EKS 2A, they're good. They're in healthy state, which means our setup is working. Demo gods are good so far. And what we'll do is basically the next step is basically we will the goal of this setup is cross cluster synchronization, cross cluster communication, right? So what we'll do is we'll just run this command. Again, it's just a cross cluster sync, just to make sure everything is looking good from both the clusters perspective. So it's just going to come back and say all the applications, the Hello World applications that we are running on port 5000, the services are working fine, the endpoints are working fine. So you should see the messages that should say healthy and okay, which means we are good to go.
And you can also see the different VPCs, right? From the different CIDR ranges from where the IPs are coming from for the
Correct.
Hello World service, right? The first one is 10.1 and the second one is 10.2, right?
Absolutely, yeah. When we created those two different VPCs, we specified 10.1 and 10.2 networks. So we're making sure these endpoints are kind of healthy. The next biggest piece that customers love is, how can I establish cross-cluster load balancing, right? So this is a bigger piece, cross-cluster communication, load balancing. What I'm trying to showcase in this demonstration is, if I call my V1 and V2 from my cluster 1, the gateways should be responsible in helping me discover and have or establish that cross-cluster load balancing from the cluster. So I have a simple script. I'm running few iterations of it. So if you see the command, it says I'm running 1 to 10 iterations, and I'm just using kubectl exec, and I'm execing into the sleep container here. Remember EKS cluster 1, cluster 2. I have these sleep containers running. Again, these are just simple containers, not consuming any compute. This is just for demonstration purposes to make sure the setup is working, right? So we're using the sleep container to validate the setup. So we're just calling the hello world, and you should see the cross-cluster load balancer work. So you should see the responses kind of load balance between V1 and V2. We are running, as we looked at the console, we looked at V1 was an EKS 1A and V2 was an EKS 2A cluster. So EKS 1A and 2A. So the cross-cluster communication is working. Again, thanks to the beauty of East-West gateways, we are relying on them to establish this cross-cluster load balancing. And if I'm sorry.
No. I just wanted to say the key here is that you have a single Kubernetes service, right, called hello world.sample that's
Correct.
basically created in both clusters, right?
Correct.
And that hello world.sample has I'm assuming a selector label that load
Correct.
balances between all pods. Well, load balances between all workloads that have, let's say, app hello world in their labels, and it's basically going cross clusters, right?
Yeah, I was about to talk about that as the next step because
Okay.
again, you may you may get the question, hey, how is this load balancing? What is the mechanism under the hood, right? I don't see when you run that for loop, I don't see anything calling v1 or v2, right? So you're just calling the hello world service, and how is it working, right? So we've used the labels and selectors we've specified, irrespective of v1 or v2, just load balance. And wherever the service is running, v1 and v2, the service is majorly responsible in routing the traffic across both the clusters. So the endpoints, whether it is v1 or v2, we're just load balancing between them. And the east-west gateways are mainly responsible for this aspect of work.
Yeah. Couple of more questions. So this one is a follow-up from the multiple accounts connected through a hub account. Thanks for sharing your thoughts. However, in the primary model, would it not have more ongoing operational needs, considering the control plane is directly number of control planes is directly proportional to the number of clusters?
Yeah, that's a good question. Again, the way I look at it is it's all about availability, resiliency, fault tolerance, compliance. If you want to do advanced traffic management capabilities, there's definitely going to be some operational overhead because you're managing two control planes and two different clusters. And let's say you have 100 clusters, right? So it all boils down to infrastructure as code and automation. I know manually setting this up for more number of clusters is complex, but with automation, the life is easier because again, you can, as part of your Kubernetes upgrades, you can focus on Istio upgrades as well. So have what do I call a release cadence, establish a cadence where you have maintenance windows, where you focus on upgrades and handle how you handle EKS control plane upgrades, data plane upgrades, also have the flexibility of managing Istio upgrades. I do agree that it's directly proportional to the number of clusters because you're running these control planes, but look at the benefits of it. As if you don't automate it, it's a pain, but if you automate your IAC, it's more easier, even if you're looking at 50 clusters or 100 clusters, right? So there's more effort from SREs or admins managing these clusters because they need to oversee the end-to-end IAC for it. And if you're using GitOps, it makes even life easier because it's you're using solutions like Flux or Argo CD to basically automate this end-to-end.
And then another one. So, what would be the implications of having a single mesh and a single network spanning both clusters in this example?
Yeah, the single mesh, if we just run it on one cluster, let's say that cluster running in US East 1 has an outage and your Istio is not functioning well, and you have some resources running in EKS cluster 2, which may be running in other region or maybe same region. So you do not have the Envoy proxies would function, but any new service configuration that you want to inject into those Envoy proxies, that is going to be problematic. So the bigger challenge that we have is the single mesh implementation is consider it a single point of failure, right? So my control plane is down. My Envoy proxies would still work because they're not relying on, they have the existing proxy configuration to do the job, but any new configuration that you're trying to push out is not going to work because your control plane is down. So the benefits of having two control planes, kind of think of active scenario, right? So those two clusters, two control planes, one goes down, the other one is still responsible in pushing those proxy configurations.
The other thing of like single versus multi networks would be the IP address exhaustion at some
Correct.
point, right? So if you have multiple networks, you can basically scale more within those networks. Well, twice as much at least, right?
Correct.
Versus if you have one.
Yeah, that's a good point too, because if you're just using a single flat network, IP address exhaustion is a common problem that we've seen. So you basically would, you also have the benefit of running two different networks, separate them. It
Yeah,
makes sense to run more pods,
yeah.
isolation, and not worry about the IP address exhaustion.
Yeah,
That's a
yeah,
good point.
yeah. But technically, like single network versus multiple networks, you're still gonna have the East-West gateway, right? You're still gonna have it in both cases. You're gonna have it for Istio Ds,
Correct.
control planes connecting, right? Well, sending configuration with multi network setup. The East-West gateway is also where the pods will talk to each other through that, right?
Correct.
Whereas in a single network, they're directly accessible, right?
Correct. They're directly accessible. You don't need the mechanism of East-West gateways. It's just you expose your API servers and then you expose your services to the other clusters, and boom.
Yeah, yeah. All right. Anything else you wanted to show us in the demo, or
I just showed the cluster one. I quickly
mhm,
will run through the.
the other way around?
Yeah, I'm sorry, I copied the wrong command. So now I'm switching to the context two, which is my cluster two, and I'm just going to call the hello world application. And you should see I have v2s and v1s.
Yeah, there we go. Yeah. So it's basically the same thing. It's just calling it from a different source, right?
Correct.
A different source pod.
Correct. So I showed cluster one before, and this is cluster two. So showcasing cross-cluster connectivity and cross-cluster load balancing.
Hmm. All right. Well, I'll switch to this view because I think we're done with the demo. Well, this was very useful. It was very practical, I would say. The To actually see this like on AWS, right? To see how this works. What are some of the different things that one needs to think about, like the common root of trust. What is the East-West gateway? What is it responsible for? And then why having multiple control planes is more. Well, not more, it is highly available versus if you just have a single control plane, because if that single control plane goes down, your mesh will still function, right? However, you won't be able to, well, you will be able to apply the configuration if you wanted to, but nothing's going to happen because if the control plane is down, it's not going to be able to translate the configuration and then send it to the proxies.
Correct.
We can wait for another, like a couple of maybe a minute or two, if anyone has any questions or if you have any parting thoughts that you want to share with everyone before we wrap up.
So we are, this is again one implementation of it. So there's going to be more advanced patterns that we are going to build and some improvisations that we'll make to the existing code. Again, the goal is majorly to help all customers running workloads on EKS, make life easier for them so that they can use this as a reference implementation. Again, not telling this is production ready because each customer's implementation will vary, but use this as a reference. But yeah. We'll be working to build more patterns. Just wanted to share that.
Yeah, and I'm sharing the GitHub repo on the screen as well. And I think there was a question early on where if there's going to be more scenarios, right? I'm assuming the GitHub repo is the place where people will see more scenarios if you all add
Absolutely.
them, right?
Yeah.
Yeah, so that's one thing. I also want to mention again, like Solo is partners with AWS, right? So we have our offerings in the marketplace, so you can go and check those out as well. One more question that came up. Let me see. So for scenarios where the same logical service is deployed to multiple clusters, do the relevant virtual service entry, destination rules, etc. objects need to be duplicated in each primary cluster?
Yeah, and again, for scenarios like this, this is where you need to replicate some of these aspects. But like the way I have demonstrated today, it's the same application but different versions of it. If you just use labels and selectors and rely on east-west gateways, you don't have to duplicate. And again, we talked about the SNI piece, right? So if you're using auto pass through and you have a service, you're exposing star.local, you don't have to. But in scenarios where you like you have different labels, different versions, but it's the same service, or it's just the same service without versions, there is definitely a requirement for you to duplicate some of these, especially the service entry piece, the virtual service piece, and then tie them back to the gateways.
And Jeremiah is asking, how many cluster services can this scale to?
So right now, this is two clusters in a single AWS account, two different regions, but you can repeat this pattern across multiple clusters. It's just changing some of those Terraform variables, and then you can duplicate the setup. Again, it's just running multiple instances of it, right? So you basically duplicate the repos and then run them across multiple clusters. Again,
Yeah.
standard is Kubernetes standard, 5,000 nodes, 100,000 pods, 300,000 containers.
Yeah. A lot of stuff that one can run, right?
Yeah.
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 All right. Well, thank you very much, Sanjeev, for taking the time and talking through this. I hope the viewers found this useful as well. And yeah, if anyone has any more questions, we're gonna wrap up. If you have more questions, you can reach out to me. Where can people find you, Sanjeev, if they have any questions they want to ask directly you?
Yeah, I mean they can reach out to me on LinkedIn. I'm happy to. I've been helping a lot of community members addressing some of their questions, especially with respect to AWS. Happy to chat with everyone on LinkedIn.
Okay, so LinkedIn and yeah, YouTube. If you're watching on YouTube, you can leave comments, questions there. You can ask questions, connect with Sanjeev directly on LinkedIn. You can connect with me directly as well if you want to ask questions, and we'll, if we can't answer it, we'll find someone who can answer questions for you. Right?
Yeah, I just shared my LinkedIn link in the chat. Yeah, feel free to send me a DM, and happy to chat and talk more about service mesh or any other topics that you're interested in.
Yeah. So I'm gonna flash a thing on the screen so people can check it out. Well, thanks again, Sanjeev. This was very useful. Hope everyone also found this useful. And if you have any questions, as I said, questions, comments, let me know. If you have any ideas for any future episodes, if you've done something similar or something around Istio, service meshes, Envoy, reach out. We can get you on and share your work with others. Thank you very much, and I hope to see everyone in a couple of weeks on another Hoot. Thanks, Sanjeev.
Yeah, thank you, Peter. Thank you very much.
Bye.